Welcome back. So we have discussed two topics, right? One is zero shot prompting, few shot prompting. And before going to chain of thought, if you have not watched the previous one, I've illustrated a way wherein you can start writing code using vibe coding in a way like you take help from the LLM and just code, wherein you can give the IP address on the prompt. It will go to Gemini. It will get the decoding. It will come into the format that you requested and come back. The reason why we wrote that is like we wanted to showcase like how we get into the usage, the practicality of it, than like manually operating the prompt at a GUI level. I have also shown like how can you start with a simple thing like adding two numbers. So even today I'll follow the same methodology. First we'll see like what is chain of thought, and then like we'll write an API call to Gemini to get the same COT example. A fascinating thing about this is like we have two interview questions today that we'll use as a COT example, and let's see like with the previous knowledge that we have built up, how can we like get into this. So zero shot, few shot, now COT. So guides the model through step-by-step reasoning for complex tasks. Now this definition is going to be very, very important. There are two reasons, couple of reasons, not only two. First, when you say like the instruction, think step by step. The keyword is like step by step. The moment you say step by step, LLM behavior changes completely. Like that's the keyword which tries to communicate to LLM, okay, stop, think in a logical way and think along certain kind of steps that I'm going to tell you. What's the application? Solve math problems by breaking them into logical steps. It can be for any of the logical problems or any of our networking problems as well. Let's see like a good example here, right? A network engineer is troubleshooting a connectivity issue. Users report intermittent packet loss. Server is connected to switch A, uplink to router B. Ping test show 10% loss between the user's workstation and the server. Right. This is an interesting prompt. Let's think step by step to identify the possible cause and solution, analyze potential causes, consider hardware configuration, propose a step-by-step troubleshooting plan. This is technically a very solid way to update the ticket, to be honest. So it checks for the physical connections. It gives us some step-by-steps. By the way, this is the expected output that we are seeing on the screen. Verify switch and router logs. Okay. Perform a trace route. Nice. It does ask us for check for CRC errors and stuff. Check for high CPU utilization on switch A. Wow. And router B, which could indicate resource exhaustion. If no issues are found, inspect firewall rules or cost configurations. Not bad. What's a bad prompt? Again, like users are experiencing packet loss when accessing a server. What's wrong? Think it step by step. Like even though if you give it step by step, if you do not give like enough formatting rules, it's going to like cause a problem. So it comes up with like couple of them which are not qualitative anyways. So let's go back to the aspect of it, right? Now let's tackle the first interview question that people generally get, and these two are my fundamental interview questions when I ask folks as well. Like, a user reports they cannot access the internet from their workstation. The workstation is connected to a managed switch which uplinks to a router providing internet connectivity. Other users on the same switch have no issues. It's mostly CCNA sort of scenario, right? The workstation receives an IP address via DHCP. Explain step by step. You see, like that's what I have covered it. Step by step, how you would diagnose and resolve the issue. And we were speaking on the format, right? So if you see, I've added separate prompt saying, another instruction I should say, saying format the response into a markdown table. Let's remove markdown. Markdown is not in the CLI, so the GUI. Format the response into a table with the below column parameters: step, action, check, and rational. So let's see how we are going to get an answer for something like this. So let's go to trusted Gemini. The reason, like, you could be using any of the GPTs, it doesn't matter. The reason why I'm using Gemini is like it has a lot of resources that they're offering, including an API call, which can support a small business. So it obviously supports us. So let's go to the gem manager. Let's create a new gem, and we'll call it some step-by-step workstation issue analyzer, something from network switch. Let's say some example. So I've given the prompt. So let's save it. Okay. Start the chat. Right. So I'm repasting the same thing. Technically, you don't have to create a gem. The reason why I've created it is like people who are watching this video will know that there are gems, and then like there is an exclusive agent sort of thing that we get our mindset into, right? And this is beautiful, you see. So here is the step-by-step approach to diagnose and resolve the internet access issue on the workstation formatted as a table, right? Step 1, physical connection. Inspect the Ethernet cable. Check. Ensure the cable is securely plugged in. Rational. A loose or damaged cable is a common cause of network connection. Beautiful, right? Workstation IP configuration. It gives us some of the commands, including ipconfig/all, ifconfig for Linux. Basic connectivity test, ping command. Switch port status. Examine the status of the switch port to be connected. Log into the manage switch configuration, CLI. Look for speed and duplex, which is fantastic. ARP table on the switch, investigate it. VLAN membership, wow. Access control list, workstation firewall, antivirus security software, DHCP leasing, which is like fantastic IP config and release config. Alternative port by cable on the workstation side. Alternative port by cable on the switch side, router connectivity, router configuration, workstation adapter. None of this work. Escalate to the networking folks, which we are. Now this is amazing, right? Like this has, like, if this was available for the days when I was like prepping for my networking, my life would have been much more easier. Especially with, you can always have it translated to a language that you want, the multimodality. That's the next level. All right, so next go back to the second interview question. Two routers R1 and R2 are connected on the same subnet. The OSPF fans and should form an OSPF neighbor relationship. However, they are not becoming OSPF neighbors. Explain step by step how you diagnose and resolve the OSPF neighbor problem. Format the response into a table with the below column parameters. Just output table and no additional details are needed apart from the table, right? Step, action, check, and rational. So let's say, let's go back. Start a new chat. Okay, that is nice. So let's do it again so that it doesn't output as a markdown. So normal table don't use Markdown, for example. Still going for this. Let's create a gem. Okay, new gem. If it still doesn't work, we'll use GPT. This is just to illustrate the GUI aspect of it. This has nothing to do with how LLM behaves and stuff. Okay, start chat. Yeah, I think at a gem level it just works fine. All right. So for the OSPF troubleshooting, right? Verify physical connectivity, check interface status, show IP interface brief, show interface, verify IP addressing, check subnet mask consistency, verify OSPF configuration, section router OSPF or show IP OSPF, check OSPF area configuration, verify network type, hello dead intervals, authentication, check for ACLs, passive interface. Wow, I almost forgot about passive interface. Examine OSPF neighbor table, show IP OSPF neighbor, review OSPF debugging logs, check router ID conflicts, verify MTU consistency. This is amazing. This is amazing, right? And most importantly, if you see, the format still stays the same, including like the step. Like here, for whatever reason, I didn't use block letters or camel case. It was just there and it followed it as is, like it still maintained consistency. So that's the power of an LLM. Now what I'm going to do is quickly do the OSPF example. So let's test the API calling feature. The reason why we are doing it is like we'll get introduced to vibe coding and also have the same prompt implemented via API so that you folks can like get and start implementing a few of these things. It's nothing difficult. I'm using Cursor. You can use like VS Code or anything of that sort. So we'll say OSPF prompt Gemini something, right? So I'll say a function to test OSPF chain of thought prompt in Gemini. That's my API key. It's a free API key. Anyone can like get the API key. So let me copy the prompt. It's done. Let's initiate the response. We'll use Gemini 2.0 Flash, and that's my response text. And that's about it. You have seen like how it gives everything in the Markdown. Stub area configuration, access list, network type mismatch, OSPF process state, debugging. Like the more context you give it to it, right? I need it in a form of a Juniper router, a Cisco, or troubleshoot it across like across a 3560 switch or a multi-layer switch. The more you give like the context, the easier it is to understand for the LLM and then help you. There are more interesting aspects of it. We'll develop the tools, which is called function calling. We've already done one video for the trace route, but more realistically, we'll build it. By the time we complete it, we'll also include something called function calling and start calling functions on the networking devices. So thank you so much. I'll see you in the next video.